Hello, friends. You have seen the consolidation process. In the consolidation process, you have seen that the moment we apply the load over the saturated clay soil mass, its pore water pressure increases. That load is going to be transferred to the pore water and its pressure increases. And with the passage of time, that increase in pressure, it dissipates and transfer that pressure to the soil skeleton, resulting in the settlement of or resulting in the reorientation of the particle and decrease in the void. So when the water goes out, the excess pore water pressure goes out, the ground is going to settle, and that process is called consolidation. So in order to calculate the consolidation settlement, the three parameters are very important. What are those three parameters? The three important parameters are: number one, it is called compression index. Normally we call it CC. The another important parameter is called swelling index. Swelling index. It is called CS. And third is called pre-consolidation pressure. Pre-consolidation pressure. So we will try to understand that how to compute this compression index, swelling index, and pre-consolidation pressure. So this compression index, which you will be using for calculating the consolidation settlement under the applied intensity of loading over the ground, let us say that this compression index can be found out by performing a consolidation test in the laboratory. You are going to have a consolidation ring. In the consolidation ring, you can have the sample. So clay sample can be brought uh, in this ring. This ring is called consolidation ring. The diameter of this consolidation ring is going to be 6 centimeter, and the height is going to be 20 mm, that is 2 centimeter. You can put the porous stone here below this. There is the porous stone. Here also you can put another porous stone. And then you can have a loading pad here made of mild steel. This is called the loading pad. And this whole arrangement is placed in this container where it is placed under water. So the soil sample which you have brought from the site is going to be underwater and gets fully saturated. And then you can apply the load and measure the settlement of this sample with the help of dial gauge. So you have got loading arrangement, and under a particular load, you can measure the change in the readings of the dial gauge, and therefore you are in a position to compute the settlement and over a period of time, and you can find out the void ratio. So under the given increment of the loading, let's say the increment of the loading sigma prime. So under the given loading, you can get the void ratio from the dial reading, and you will be able to get the value of compression index. So compression index can be easily found out by performing the test, and if you perform the test, you will be in a position to get the value of the CC value. So CC, if you plot it, you are going to have initially the void ratio reduction will take place. So it is going to be like this. And if it is log sigma prime, then you will find that there is going to be a straight line, and slope of this is going to be for any given pressure is going to be E1, this is going to be E2. So E2 minus E1 minus E2 upon log of, this is going to be sigma 2 prime, sigma 1 prime. So log of sigma 2 prime minus log of sigma 1 prime will give you the compression index, or you can say the change in void ratio delta E divided by log of sigma 2 prime upon sigma 1 prime to the base 10 is called the compression index. This is very, very important parameter for computing the consolidation settlement of any footing, or wherever consolidation settlement computation is required, you will be needing this CC value. So E2 minus E1 divided by log of this. So one important, but this comes out from the consolidation test. There is also some empirical relationships given by various researchers. The most popular is CC equal to 0.009, liquid limit minus 10. There is another empirical relationship that's being used. Then the swelling index, if you are going to have this, you will find that if you are going to decrease, unload it. So in the unloading phase also, you will be getting the line like this. So let's say this is E3 and this is E4, and the corresponding vertical is sigma 3 prime and sigma 4 prime. Therefore, CS, the swelling index, when you are going to unload it, can be also found out as E3 minus E4 divided by log of sigma 4 prime minus log of sigma 3 prime. So the another important parameter is called pre-consolidation pressure. How do you find out the pre-consolidation pressure? When you are carrying out the test, you will find that you can have here sigma prime, and here the void ratio, and then you get the curve like this. This is on log scale. This is the void ratio. You will get a curve like this. Now here in this part, find out the maximum curvature. So maximum curvature point, and term it as O, which has got minimum radius. At O, you can have a horizontal line as OA, and this straight line portion, this portion is a straight line. So this, if you take it in the backward direction, this intersect this particular point at some OA, or you can draw a tangent over here at point. So this is the tangent that I have drawn at O. And so let's say this is B. Now divide this angle AOB. Let's say this is D. So I have divided it. Now this horizontal part, if it is taken in the backward direction, it is going to intersect this OD at some point, and that point, let's say, is called E. And this is called the pre-consolidation pressure. So this pre-consolidation pressure can be taken as sigma P prime. So pre-consolidation pressure is also important. So these three terms we will be using this one. And what is pre-consolidation pressure will come in the next video. So thank you very much.